Our second video for Chapter 3 is looking towards these bones, the femur and the humerus. Our setup, considering the data on the lengths in centimeters of the femur, the thigh bone, and the humerus, the upper arm bone, for 5 specimens of Archaeopteryx, it's a genus of a bird-like dinosaur, that preserve both bones, right? So we're looking at this data of these fossils that had both this femur that many mammals have, as well as this humerus that many mammals and other species have, right? So we're going to make a scatter plot and describe what we see. So give you time to make a scatter plot, unpause the video, check the information, and we'll go from there. So your scatter plot should look a little something like this, right? Make sure that you label your axes on your scatter plots, right? Now, different from making a histogram or making, right, those sorts of setups, bar graphs, all of that, it is completely okay for us to break our axes, right? So here's where our X data is, where our Y data is, right? So the X data, I start at 30, that's fine. The Y data, I start at 40, that's fine. What matters is here's what I'm looking at for my data. And if I were to come over here and look to fit a line through these data points, right? If I look to fit a line through those data points, right, I can come up with the description of my relationship, right? And what would be that description? Well, that would be that there is a strong, positive, linear relationship between the length of the femur and the length of the humerus for the species of our Archaeopteryx examined. Right? When we're describing what we see, and I apologize for shorting out the justification and the other things on the first video, right? But we always want to give the context, right? Whatever we're doing, always give the context. So we have a strong, positive, linear relationship, and what is this relationship representing, right? It's a relationship between the length of the femur and the length of the humerus, right, for these particular species of Archaeopteryx examined, right? And why is that? Well, because we have a positive slope, and there seems to be a line that fits closely to all of the data, right? This details we're going to get further into in different videos. All right. Now, additional facts about correlation are very important. So first, we do have a correlation coefficient, which goes with the letter R. That does not change based on the selection of explanatory or response variables. So if I switched the humerus and the femur, the X and the Y, right? If I change these, right, these axes, I would still have a positive relationship. It would still be strong. It would still be linear, right? That correlation, right, does not change. Why not? Well, because the correlation, right, this R measures the strength and direction of a linear relationship, right? What's the strength? It is strong. It could be moderate. It could be weak. This one is strong, right? What's the direction? Is it positive or is it negative? Or is there no correlation, right? And we are going to always be linear or nonlinear. Why? Because this correlation is specific to a linear relationship. Okay, now further, correlation is without dimension or unit. It is just the value, right? How strong and what direction is the relationship, right? Now, specifically, it measures the linear relationship, right? The correlation measures the linear relationship of 2 quantitative variables, not qualitative, right? Not categorical. They must be 2 quantitative variables for me to do this linear regression. Okay? Correlation, right? This R, correlation coefficient also, is not affected by changing the units of measure for the variables considered. So if I was going to say, hey, I'm going to have the femur length in inches and the humerus length in inches, not going to change the relationship. If I'm going to have the femur length in centimeters and the humerus length in inches, not going to change the relationship, right? the slope might change, but it'll still be positive, the relation will still be strong, the relationship will still be linear. Okay? Then, the concept correlation does not imply causation, right? Just because the femur length is long doesn't mean that's what's causing the humerus length to be long. All we're saying is that long femurs tend to be in association with long humeruses. Okay? Now, there's some nice studies on this ideas, and you can research chocolate and Nobel Prizes. There's several scholarly articles and other newspaper articles and research articles regarding the correlation between chocolate consumption and winning Nobel Prizes. It's something that's fun you might consider checking out. And most important of all, most importante, always look at a scatter plot before describing any relationship through correlation. If you're not looking at the scatter plot, don't trust your answer. Okay? Make sure you're completing all your work, asking questions for clarification. Right? Have a wonderful day.